Okay, my friends, as you know, Roger once again, and I am a researcher. So everybody's talking about dark matter now. They've been talking about it for over 100 years. Nobody can figure it out. We can't figure it out. We can't find it. Well, I think I can actually show it to you, and I will, but let's see what they have to say. This is Paul Sutter, and at least he's saying, have we gotten dark matter all wrong? Let's see what he has to say. And now there's new discussion about there's a region in space they have found it contains no dark matter. Now, they say everywhere contains dark matter except this one region that they can find. This is a strange time in physics, my friend. Very strange. Let's see if we can sort this out. Okay. Physics is not as difficult as you think. I'm going to make this so simple that a young child could understand this. Now, a child on a merry-go-round spins around and around and around. Now, the faster it spins, the more likely the kid's going to get thrown off if he's not holding tight. Everybody understands that. So if galaxies are spinning, which they appear to be spinning, why don't the planets and everything go flying off? Why do they keep compressing closer and closer? This has to do with this dark matter. And they might, this is exactly correct, we might need to radically revamp our understanding of the fundamental of physics. And yes, because everything there is a dipole. So everything changes. They had monopoles. They had a positive core, 100% positive, and then nothing but electrons on the outside, 100% negative. That has some validity to it, but not much. And I'll try to explain to you why. Because everything is made of dipoles when you get down to the absolute fundamental particles, the basic absolute fundamental dipoles that make up protons, neutrons, and everything. So they start with the tiniest dipole, which is a little black and white particle. Shown it many times. You're going to see it again today many times. All right, listen to this. It says here that if scientists don't find more concrete evidence for dark matter soon, we might need to radically revamp our understanding of fundamental physics and with it the universe itself. Well, I have found the dark matter, and yes, we need to revamp virtually everything. Chemistry all the way up, right from the very, very fundamental particles that make up everything. And yes, the universe and the biology of the universe. We have to start right from scratch, my friends. And this is being pushed back at very, very strongly by academia, who finds this very, intrusive. But truth is truth, and you're going to have to pay attention to this if you want truth, because you won't hear it at universities. This is going to be something that you're going to have to pay attention to yourself, then make your own decision. Okay, let's talk about why we need to revamp everything about physics. The universe is supposed to be a vacuum outside of the particles that are in the space. Everything else is supposed to be nothing out there, a vacuum. That's just not true whatsoever. Okay, we do need to radically revamp everything about physics, and here's why. Let's just take a look at what space is like. The reason they think there's dark matter is because of its interaction against the matter we can see, the glowy part matter. So why do they say there's dark matter out here? Well, obviously these arms are being bent back here as this thing is spinning, and the arms sticking out like on a merry-go-round are pushing against something in front of it, so it's bending them back. All right, otherwise they'd be sticking straight out. They just keep going straight, go flying out like that. And they are not. They are spinning and being crushed backwards. So there's obviously something in space here. And that is the reason this is glowing. The reason these arms are glowing is because they're impacting with space, which you don't see because it is dark matter. But I will show you light going through the air, impacting dark matter, making it just start to glow. And we did all kinds of light experiments. You're going to see the results of that in a second. All right, I'm going to show you this exact same thing, only as with a light, with a laser. light spins like this. It's spinning and it's scrubbing what's in front of it, twisting itself backwards. Now let me show you what happens with actual light. Light doesn't flap like this. Light spins just exactly like that. And at the tip of every single wave is a magnet, basically, is a dipole. And as it spins through, we had a slit with a Venturi, and some would go this way, some would go that way. I'm going to show you that right now. All right, get ready. All right, we're going to go through all of these, but this is the spinner, and this is light through a Venturi. That's the pattern it makes after it comes out the other side of the Venturi. So the light is spinning, just like I showed you with the galaxy. Some goes off this way, some goes off this way. And this is on the other side of the Venturi, on the wall, the pattern the light makes. And that's what's called interference patterns. They are repulsion patterns because of magnetism. And they are the same thing that we see, these glowy little lines right here. Each one of them pushes against each other's line. This is push to shove, push to shove, push to shove. That's what causes these glowing particles, and they say the same glowing particles that you find in light. You see this? Let me turn the lights off because it makes a better presentation normally. Now, this is nothing more than a pulsed red laser. Bip, 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 bip. Well, this is the very leading tip of the pulsations. So it is the most interactive with all the particles that are in the air. That's why it's glowing more brightly than anywhere else, because it's wherever you push and you get shoved back, you get glow. That's energy. Energy is mass. That's correct. Einstein was right. Energy is mass. It has nothing to do with the speed of light. Mass has to do with everything, as how fast it's going, how heavy the particle is in the first place, and secondly, what it hits up against. Speed of light comes up and down, as it's not a constant whatsoever, and I'll show you that quite clearly as well. So there's particles in here, not just one, there's a bunch of them. And these, every one of these is a gas in the air or an extra electron, and then the electron is the white part. You'll see this in a second. They glow. The black part just stays around with them. It hugs up to them. It does not glow. And here's the particles themselves. This is exactly what they look like. Now this is the neutrino phase, where the particle, same particle, but it hasn't got enough energy, or it's got too much energy. I don't know what's going on at this point. But then it shows up as a photon. See, here's another, this is neutrino, neutrino, photon. And then still another photon. And then here it slams into the Venturi and all bets are off. It just turns into the white and the black particles separated. And that I can show you as well right here. There it is accelerating, and it has to accelerate to go through this Venturi. A Venturi is known for that. That's its function in life, is to accelerate things, and primarily gases and fluids. And light is nothing more than a gas or a fluid. I call it atomic vapor. It's just like a gas or a fluid or a smoke or whatever, but it's a particle. And the particle has both the black and the white, and here it is starting to gain energy. The white is starting to glow, and it will glow like crazy, and I can show you that as well. And here it happens to be just exploding glowing. And this is what's called a white electron shower. This is subatomic nuclear explosion. Fission here, the black comes away from the white. Fusion here, it comes back. Here is raw white electron energy. This is some serious energy. Now, if we can harvest it right here, which is what I'm asking for, if that could be done, I think we could get free energy, because the energy back here is very weak compared to the luminosity here. Luminosity is the definition of energy. When you go from low luminosity to high luminosity, you gain energy. Case closed. All right, here's the same thing. Here's the green coming through the Venturi, and these are the particles as they form, as they recombine. They turn into photons out here. The red does it a little different, it appears. The red creates the photons before they hit the Venturi, and then when they come back together, I got to be honest with you, I'm not 100% certain what, but here they are coming out and breaking apart here and coming back together here. Now, what they do in this is they come back as Higgs. In a green, they come back as photons. These are photons coming and showing up out here. The red does not do that. The red shows up out here as Higgs fields. These will turn into Higgs fields, I think, eventually. So the red just is not concussive anywhere near like this. Here's what happens with the red. The red comes through. Okay, right here. It accelerates. You saw the black and the white together, and then they just split apart. The white goes through, and it comes back together with the black here. But when it comes back together, it doesn't come back as a photon. It comes back as a Higgs field. And the green will do that as well. But here's the red. Here's what happens to the red. You see, it comes out through here, and then it just turns into these fields. Those are Higgs fields. The green will absolutely turn into Higgs fields as well. But the first thing it does is, instead of just going directly from the raw white to the Higgs, it goes from the raw white into the photon phase and then into the Higgs. I believe that's what because it's just more powerful. It has to step down a phase. This doesn't have to step down. It can just turn right into the Higgs. And it did some very interesting things. This is really interesting stuff. See, here's the green. The green coming out of the Venturi and then turning into the photons. All right. Ours, when it came out of the Venturi, it just turned into the white showers and then back into the Higgs. This is a kind of a unusual one. You see all the little black particles coming off to this side? Those are all of the muons. There's none over here, zero. So, and I can see the Venturi is not equal on one side or the other. So it's like banging and sliding off, because these are the hard particles. This is just letting the light particles push away and come out here, because the white ones will push away from each other. The black particles are being forced to come this way, but the white can push away from each other and create these waves of fields. The black just sort of pushes, and it is very small amount of black compared to the white when they start to compress like this. Look at this. This is, where is it? Here it is. This was amazing. And again, this is Rod Warren. This is not me. And when you hear an atomic bomb blast go off, when you see the brightness, you hear, and that's this pushing of the electric fields. And this right here is all there is of the black. It doesn't grow, it doesn't do anything, it just pushes the white ahead of it. And that right there will burn a house down without even knocking the house down at all, until the black comes, and then out goes the house. Now, if we could stop the black from ever getting through, and all we had was the white, we could run this forever and just keep collecting the energy. So in other words, which we did right here, there's no black getting through. This one here has no black. The other one I just showed you is wide enough or something. He did something. And again, the Rod Warren, it's not me. He did something there to let some black, but just a little bit, so we could see that wave. And then you could see the ripple ahead of it, which I'm going to do the atomic bomb blast to show you, because we'll be able to hear this. No movement, you're just going to hear, and that's this leading the explosion of all of these particles. And the reason you're seeing all those ripples is because it's push to shove, push to shove. I push you, you shove me back. Next one, and they go really tight, and then they open up, open up, open up. That's what happens with the magnetic fields. They start to slow down. All right, this is a dipole, which means a black and a white is a positive and negative, just like a bar magnet, spinning like crazy through space, creating these magnetic fields. Well, what is a magnetic field? There's all the energy is down here. That's, well, not all the energy, but most of the energy is real, and they're tight like this, and it goes, and it's pushed, and it gets to the end here, and then it loses its field because it can't push and shove back anymore. It's at the last end, but down here it's tight, 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 and these are the poles. So it's spinning this way, and just click, 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 as it pushes back and forth against the particles it has to interact with. That's what creates these fields. That's what a magnetic field is. So why would light just coming at us create these fields? Because it's going pop, 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 trying to push through. But it's slowing down as it's coming through this. And I can show this with the blue. It's hard to see in some of them, but the blue we can see pretty clearly. This is coming through the Venturi, really hot. That's a tight spin. And then it starts to open up and it starts to drift off because it's spinning to the right and it will drift off to the left. This is one segment of camera shot. So down here we can see it is made up of the same two particles that all the rest of them are, but the blue is really hard to see. The red and the green are quite easy to see. You see the green right there? This one right here is getting ready to flip. You see how the white one's charging up? That's this one charging up, and it's going to go whoop to the back, and this one will come to the front and start to charge up. That creates the spin. These particles spin. This is a cool shot. This is the Venturi is in here somehow. And again, I didn't take these shots, so I just analyze them the best I can. But I can tell you what, this is the pinch. Wherever you see the white, it's a pinch. And you can actually see the particles heading in. I don't know, I'm not going to try to explain it more than just to what I see. But I can see that it appears to be that they're spinning in this way after they come out of the Venturi, which they all spin, and they want to get away from each other. They're just pushing each other away. White does not want to be next to each other. The glowing ones say, get away from me. In between is the dark particles. And then all of a sudden they fluff up into the Higgs fields. The white particles coming through, but only on the red ones. The green ones react a little differently. They step down a step and then turn into the Higgs. Like this here, they step down a little bit and then they turn into the Higgs. It appears to me, I don't know. It's, you know, this is, I'm doing the best I can with what I got. And then this was the real killer. Now don't forget that, let's just start with the white showers coming through, creating the Higgs fields. So let's start with that. They come through the Venturi. Here. And then they come out of here, and right here they create all those Higgs fields. Is where the black particles come back together, or to the white particles. So they slam into them. And here is that event right here. So that's where that line of demarcation is. All right, so here we are out here, and we're looking directly into the white shower. Well, way out here, they're hitting and creating these fields. This one here, that little white particle, appears to be spinning backwards. It didn't make a normal field like this. It's an energetic little particle, but I think it's dragging its field into itself, and then it collided with one of the normal Higgs and created a very strange event. Very strange indeed. And here it is right here. I believe this is that reverse spinning particle. All right, and it makes total sense when you think about it carefully. You can see there's some structure to it. Whatever that is, I don't know. I say it's spinning backwards, so in other words, it's spinning this way. All right, let me put the light on. All right, no. This particle here, I say, is spinning this direction. The normal particles should be spinning this direction. So this is going that way, this one's coming this way. This one bumped into this edge right here, and it stripped it off. So this one's going this direction, this was going this direction. Well, it grabbed a hold of it and it's spinning it, turned it really hot, and a little tiny cone coming off. I don't know what to think about that. Other than that, I believe is a reverse spinning particle. That's the only one I've ever seen of it. And it interacted with this field, and the only way I can account for the shape and the intensity of the increase in energy is because this stripped down and stripped this particle edge off and sent it off this way and just stopped the particle from turning into a field. It looks like to me. All right, this is both the red and green at the same time. Green, very, very powerful. Red, not powerful. Low luminosity, high luminosity. High energy, low energy. This is coherent laser light, just one color. CERN and all the rest of them are using protons. They get every different color. They get all the blue, the green, the red, the orange, the yellow, all that. Because they just spewing out all kinds of particles instead of one frequency of energy. They have all the frequencies and smashing them into bits and pieces. All right, this is what CERN and the Fermilab and all them are doing, taking a proton, which is all the charge bits, and a neutron, and they smashing them together, and they're getting all kinds of debris. They're getting chunks like this and like that, and all the way down to little bits and pieces of the photons, and all the same particles I just showed you. But they think these are just one little balls of glass like this. And they're not. They are all particles. Every one of these particles is a dipole. That's the dipole flood theory. So they're seeing all of this debris, literally debris. We're seeing the actual particles that came from the light. This was what light starts like. You saw it. It was light, real stuff, not just drawings. No, I think this was 2014, 2015. The Russians showed that you could separate these particles in space in a vacuum chamber, charged micron-sized dust particles, injected into this vacuum chamber. They created this. They flipped out. They had no idea it would do this. They figured it would create a lattice. And it created this black hole. And I understand why. So I got a hold of the Russians and Fermilab at the same time, and Fermilab was not interested. Anyway, that's a whole other story. But this was Fermilab's article about this, the black and the white particles. Here they are. These are the ones we found. Exactly the same. And it didn't go well with Fermilab. Let me put it that way. They don't. Just let's leave it at that. But this is the light. That's the light coming through here, and then it splits. So what do we have? We have the two particles, the fixed particle that Fermilab had a big long thing about. Fixed particle never changes size. It just has a big mass. And then they see this one, which gets bigger and gets smaller and has no mass at all. They call it a point particle, fixed and point. Now, I said, we found those in light. They're stuck together just like this. One of them gets big and glowy as it pushes through, and the other one gets small, and this one never changes. Never changes. It's a certain size, and we've got it so that it can't get through the Venturi. All right, the Venturi is too small for the black to get through, but it can squirt the white because the white can get big and small. And that's exactly what they said too. Muon neutrino, electron neutrino. These are the two. The muon is the black, the electron neutrino is the white, and turns into electron showers. The black just goes on by itself. It's exactly correct. And they recombine this far away. All right, so that's got to be fission because they came apart. That's got to be fission. This has to be fusion because they came back together. I see no other way to just even think about it. And I'm having a hard time getting through to anybody. And this is something that could possibly create free energy. I mean, seriously, and quick, within weeks. If this works, I cannot do this. But all we need to do is take a laser and start with that low energy and force it to crush its own fields and squirt out the white only. And all right, let's just think about this. If we could accelerate that light through that Venturi and get this result, and all we want is the white. The white is what does all the work. And if we can put it through a photodiode into some capture device, batteries, it doesn't matter. You can just run it right into your equipment. Because as long as this is running, it's going to be a continuous feed. And if it is this high energy, which it certainly looks like it, that continuous feed should be in excess of the input energy. And if that's the case, that's free energy. And all you have to do is scale it up. And this is handheld stuff, and you could carry it around with you. All right, this is literally stunning. If you look back at these little dots here, every one of those is a gas particle, a molecule in air, oxygen, nitrogen, hydrogen, whatever it is. This is such an absolutely unbelievable amount of reverse energy. Look at this. This is the reverse concussive waves. And now, this was just a very simple Venturi. So we're losing all of this energy, but look at the energies coming out of here. Now, if we redesign this in such a way, and I have some designs I've thought of that could capture most of this and not let it just all blow back out this way. You see this here and this here and this here. Those are other light particles coming forward, but you would never even see them because they're not energetic enough. Now they're being pushed back at so hard from this reverse electromagnetic, and it's called our reverse EMF, reverse electromagnetic force, and it just bang backwards. Field to field, a field banging another field. It's so hard banging, it bangs back way back here. So my point is if we could capture this in some kind of an additional engineered device. Right now, this is very, very simple. What we could get out of there, I have no idea. But I can tell you what, this would be how we would be able to walk around and carry it. And this has already been proven. This was by Lawrence Livermore, I believe, showed that the low energy showers of the electrons, way back here, the little low energy showers, once they came through the Venturi, they go right through the roof. See, this is electron showers, high energy. So if there's low energy here and there's high energy there, that's an increase. The muons, you see the muons up here? This is the muon track. It bashes up and it bounces off. This is the electron track, the electron showers. They come through and they go from low to high. Now, if we could do that, we could carry around something like this with all these little tiny lasers, because this is what we did, everything with these little tiny lasers through a very, very simple Venturi, and that could be micro size. This is all based on the electron flood theory. So this should be looked at years ago, 7, 8 years ago. I've been trying to push this, and I can't get anybody to pay any attention. Or, and I went to University of Geneva. I showed them this, and as a matter of fact, they just put out something about very, very similar to this. I have to look that up, but they had something about. Well, I have to look it up. I can't remember. Okay, this is hard to believe, but it's true. This is at CERN, and this is April 22nd, 2023, a couple months ago. They're taking giant steps to look for tiny particles. Well, what are they doing? They are creating a tunnel 56 miles long, 5 meters in diameter, under Switzerland and France. 56 miles. The goal is to push the energy and intensity frontiers of particle colliders with the aim of reaching collision energies of 100 tera electron volts. That's 100 trillion electron volts. But it's still on a single electron. You're not reaching that like a big, huge bundle of it. You're reaching it as an intensity level. All right? Volts are the pressure. They're not the quantity. We need to get quantity and we need to get those high voltages. If we have the two of them, we're good to go. Now let me show you why I think we can do this with the design of the Venturi. Okay, this is Atom Central, and they're testing out the atomic bomb. And what you're going to see is the white particles that I showed you come through here and just burn the house up. And then the black ones will come behind it and knock the house down. Well, what if we could not let the black ones ever get to the house? Think of what would happen. Watch what this is going to happen. The white stuff will hit it and it just vaporize it. Even all the wires and the poles and everything. Anything that's combustible will just vaporize. Watch what happens. I'm going to turn off the sound because I got to run it slow. And I'll stop it probably as I want to make a point. But the first thing you see is just a brilliant flash. And that flash is when it goes off. Oh, it's gone off. Now, what happens? Instantaneously. I mean instantaneously, it starts burning. So but it's not moving. Now I'm going to let it play and just watch what happens. Watch the wires and the poles back here. Every single thing that has any combustive value whatsoever to facing this light burns. But all it does is burn. It's not being pushed. It's not going anywhere. It's just vaporizing, and it's virtually vaporized now. Now just think of this. What if we could just continuously continue that white? This thing would just continuously burn. Now what if it didn't burn? What if we could get in there and grab that stuff and put it down into our batteries? Because this is nothing more than what would charge your battery up. It's the same stuff. It's just electricity. It has no weight to it. All right, if it had a weight to it, it would push the house down. No weight. So what does that mean? It's just like your battery in your car. You charge it up. It's just now it's got plenty of juice, but you didn't add any extra weight to speak of. Maybe just a tiny little bit, but probably not even a very, very small amount. Let's put it that way. It's going to increase a little tiny bit in weight, but very, very small amount. Now, the other part is the weight part, which is coming now. That's where all the weight is. And that's the black part. So here it comes. The white is just finishing up. It's pretty done. Now watch. Boom. This is the black. It has no burn to it. None. Zero. It's cold. It sucks the white black back to it. But in this way, it bangs it all. Now everything comes back because you see it all feeding back because there's a void back where it all started from.